I want to open with a question. What do you think when you hear AI? And there has been a lot of noise, a lot of news around it, so maybe you hear or you think about all the buzz and the buzzwords, which is OK. Maybe you're optimistic about the future and you see AI as a great way to automate your job and your life away. Or maybe you're just getting started with AI and you're thinking how you can use it with blockchain and Web3 technology, right? So whichever way you think about AI, the goal of our session today is just to show you some small but practical steps that you can start taking today to advance the development with AI and blockchain technology. I'm Ed Marquez. I lead the developer relations team at Swirls Labs. And Swirls Labs is the firm behind engineering and marketing initiatives for the Hedera network. In terms of background, by training, I'm a mechanical engineer. I started doing software for embedded devices and automotive. I ended up working at an enterprise doing scientific computing software. And then while I was there, I discovered my passion for Web3, for crypto, for Hedera. And so it was a fortunate instance where the side hobby kind of became the main job, and that was about 3 years ago. And then in terms of other professional fun interests, I love to explore that intersection between blockchain and other technologies like AI and other verticals. So more than happy to connect with you. I'll be available after the talk for any questions that you may have. And so let's dive right in. In this session, we're going to cover 3 portions. The first one is going to be an introduction around AI and blockchain and explaining why these two work so well together. Then we're going to dive into the application of data integrity and model lineage. And then we're going to close with retrieval-augmented generation with blockchain. So starting with AI and blockchain, we've all seen the wonders that AI can do, right? And AI is revolutionizing many industries because of these capabilities to analyze large data sets, predict trends, and also automate very complex tasks. And we've also seen it be essential in multiple fields, like in medical diagnostics. We've also seen it used in optimizing supply chains. And one that we're all familiar with is detecting fraud in finance. Now, it doesn't stop there, right? AI is also used in many other applications and fields, and the growth potential is really significant. So just to put things in perspective, right? Blockchain and crypto, we've been around since 2008, 2009. And today, the market cap is around $2.5 trillion. But for AI, a report by PwC estimates that by 2030, the AI contributions to the global economy will be at around $16 trillion. So that is massive upside. And so no doubt that both blockchain and AI are both really powerful technologies that provide these exponential growth opportunities. Now, as you'll know, with great power comes great risk. And so one risk that we're all familiar with is deep fakes, right? Anyone can now look like Tom Cruise, or more importantly, like a political leader. And so that introduces these concerns around security and trust. And it could actually influence important processes like political elections or international relationships. There's also the risk of the use of unauthorized use of copyrighted content. We know that these AI systems can generate vast amounts of content, and they're trained on content that could be copyrighted. And so that could lead to legal and ethical issues. And we've actually seen some lawsuits fly around in the industry because of this. There's also the risk that AI decision-making is like a black box, right? It's very difficult to explain or understand how AI decisions or an AI model gets to a certain decision. You also have the risk of data integrity, because if there are any underlying biases or errors in the data, that's going to be reflected in the model as well. So this is effectively a garbage in, garbage out type of problem. And hallucinations, right? We've all experienced the amazing confidence of LLMs when they provide a wrong answer. So that's another valid concern there. And so with these risks, that's how we start to see the need for these mechanisms that help us ensure the integrity and the authenticity of AI inputs, AI outputs, and the processes around that. And so that's where blockchain is a very good solution, right? Because it's this decentralized database that introduces a transparent and immutable record and ledger that creates this transaction history and provenance for those transactions, for that data, and for those processes and models related to AI. So what I'm getting at here is that while AI provides this abundance, right, by generating lots of content, blockchain ensures the authenticity and the scarcity that we need to provide that trustworthy foundation to develop and adopt AI at a global scale. So this far, I've identified 5 key areas where AI and blockchain are a good fit. The first one being the integrity of data that is used for training these models. The second one is the lineage of AI models during the development and tuning process. Then you also have retrieval-augmented modeling, also the content ownership, the traceability, and the authenticity. And of course, auditing AI decisions, right? We all saw what happened at OpenAI, and so how can we use maybe DAOs and blockchains to improve the governance and decision-making around AI? Today, we're only going to cover the first 3, so let's dive right into data integrity and model lineage. As we saw before, the quality of the training data is everything, right? Because the quality and the reliability of the model is going to depend on that data. So if there are any biases, any errors, the model is going to perpetuate that in any inference, predictions, or decisions. Garbage in, garbage out. And so just to give you an example, right, to illustrate this, just imagine if a malicious actor had the ability to modify data, training data for a model that is used in healthcare. And so that could actually lead to incorrect diagnostics, or maybe even some confusion, right, as to the recommendations that a doctor can make. So you can see that a model could become a problem rather than a helpful tool for professionals in the medical field. And in the worst case scenario, it could actually lead to patients being harmed because of those incorrect suggestions or recommendations. And this type of scenario is not only applicable to healthcare, right? It could happen in many other verticals. So the integrity of that data is very important. It is actually so important that the National Cybersecurity Center of Excellence at NIST, they put out this comprehensive practical guide to help organizations prepare against that increasing threat of data attacks. And according to the guide, it is crucial, right, that the data integrity is maintained during transport, storage, and processing. And ultimately, that data has an impact on the revenue, the operations, and the reputation of a company. So today, data is like the new oil, right? And that could actually be used against you or your organization in these ransomware and other destructive events. So what can you do? Well, that's where blockchain comes in, right? It's specifically something like the Hedera consensus service, which gives us that assurance that the data is unaltered and verifiable from the moment that we record it. And you can think of HCS as a decentralized messaging bus, right? So it also orders and notarizes transactions for you. And you can, of course, publish and subscribe to these topics. So within those topics, you can have these messages that contain the actual data or the actual information that you want to timestamp. And of course, you can have multiple topics or as many as you want. So the important thing here is that each data entry is actually timestamped and cryptographically secured. And that gives us that immutable log or record that anyone can access and audit. And so to make this a little bit more tangible, here's the output of what this process looks like. So we can look at a topic on a network explorer like Hashgraph that gives you information about specific messages there. You can look at message-specific information as well, right? We're going to see that later, but information about the transaction and the information or the payload itself. And as programmers or developers, you also have access to this type of information via APIs so that you can use it programmatically in your applications. So now let's look at the input piece of this process, right? How we can code each one of these components, because it's fairly easy and straightforward. So to instantiate a topic, you can use Java, JavaScript, and Go SDKs that this service provides. So here, to create the topic, I'm just using this topic create transaction object. I execute it. In this case, this is a public topic, so anyone can submit to that. Then I get my confirmation, and from that confirmation or receipt, I derive my topic ID. So this is going to be important. We're going to see an actual example of this. And then we can just show in the console, hey, our transaction is successful, and here's the topic ID that we just created on a distributed ledger. So very simple to get started creating topics. From there, we can create the subscription with just a few lines of code as well. So in this case, we use the topic message query object. We connect that to the new topic that we created in the previous step, and then we subscribe to it. So we just do that with our client. There's the option to provide an error handler. And then here we provide the listener function, right? So we're just taking that message, displaying it as a string, and then putting that in the console with some additional information about the date and timestamp, and of course, showing the actual message. So we're going to see an example of that in just a few moments. So far, we've covered the instantiation of my topic, the subscription. Now let's see how we can submit information to this topic. So here, we just have a simple for loop to submit 7 messages to the topic that we just created. So hello, Hedera, increasing a counter. And it's as simple as using this topic message submit transaction. So we say the topic that we want to connect to, the information that we want to enter, right? So in this case, it's just this string. And we just execute that there. So now let's jump into the demo just to do a quick walkthrough of what this looks like in action. So what I'm going to use here, where you saw that QR code, this points to this repository. So just very simple instructions on how to get started with these topics. What we're going to do is we're going to generate an EVM address on Hedera. Then we're going to fund that EVM address to create an account. And then we're going to create a topic, submit messages, and so on. So you can clone this repo, and do it locally. I'm just going to do the quick walkthrough here. I've already done these steps. And you have the instructions there, again, to do this locally as well. But the first thing that we're going to do is we're going to look at the dependencies that we have. And what you can see here is my main dependency is this Hashgraph SDK that we provide. From there, now let's jump into this EVM or key and EVM generator. Here's how you use that Hashgraph SDK. In this case, we're only using the mnemonic object. And we can generate a new mnemonic phrase, convert that into a new private key. In this case, I'm going with an ECDSA key. So Hedera supports ECDSA and ED 25519 keys. So once we have that new private key, we're going to derive our public key from that, and then from there, the EVM address, and get that information. And then we're going to display it in the console. So if we run this here, there we see our new mnemonic phrase. Remember to keep that information private. There's the corresponding private key, the corresponding public key, and our EVM address. So now I'm going to grab this address, and I'm going to come to this faucet to fund my account. So I'll get about 100 test HBAR to start developing my application on a testnet free of charge. Oop, so we got a little error here. Let's try that again. All right, so we're getting a little issue. But if we go back to the demo, let's see if I have some credentials already stored in my .env. The joy of live demos. OK, this looks a little different this time, so it might actually go through. And there we go. So we just funded our new account with 100 HBAR. I'm going to take this account ID, bring it back to my .env file so that I can work with these credentials. I'll also grab my private key. And now with these credentials, we're ready to start submitting transactions to the Hedera network, to the testnet. So I'm going to come to this index file, and we're just going to do the same things that we saw in the slides with a little bit more detail. So here you see a few additional modules that I'm importing from that SDK. So the client, account ID, private key, and the ones related to the consensus service. And to instantiate my client, I'm just using the object, specifying the network that I want to use. In this case, the network is testnet, as we defined it in our .env. And my operator credentials are the ones that we just entered in the .env file as well. So as you saw before, we're going to create the topic. We're going to subscribe to that topic. And then from there, we're going to submit or enter 10 messages to our new topic, as we saw before. And then we're going to see that information on a Network Explorer. So if I run index.js, here I see that I just created a new topic on the Hedera testnet. That's my topic ID. The information is propagating. And here we see the subscription, right? So we see the 10 messages that we're listening to. So you see some information about the date and time and the actual message content that was sent. Now let's look at that on our Network Explorer. And there we can see information about the topic. If I wanted to look at transaction-specific information for a given message, here I see the timestamp, the transaction hash that proves the integrity of this information, some additional credentials, and here's the actual payload information. So you have a sequence number, you have your contents, and then also a running hash. So that is how you can get started using that Hedera consensus service or blockchain to submit and anchor data on a distributed ledger. So coming back to the presentation. Who's actually using this? Who's doing this in real life? Well, it turns out that OneSpan acquired a smaller company called ProvenDB that were using the Hedera consensus service to store valuable digital information or digital agreements for big institutions like IBM, Deutsche Bank, and US Bank as well. So there is a good service to provide this kind of services like a vault type of solution. Now let's look at the other part of data integrity and model integrity, which is the lineage of AI models during that development and tuning stages. And of course, tracking the development of AI models is very important to have that transparency and that accountability as the model evolves, right? If we don't have that, then it kind of becomes difficult to track how a model changes over time or how it evolves over time. Also, when you change the model in that tuning and development process, if you don't have this record of the things that were part of that process, it becomes very difficult to identify the root cause of any issues if that were to happen, right? It's almost like finding a needle in a haystack if you're not anchoring that evolution. And of course, any changes can also introduce new errors, new biases, or even malicious alterations to the data that could go unnoticed, right? So in this case, you may have industries where it's not only a best practice to document these changes, but in some industries like finance or healthcare, you might also have regulatory requirements to comply with as you change these models. And a great example of people that are doing this, right, documenting and tracking the evolution of models, is Equity Lab and what they've done with Climate GPT. Climate GPT is a model that was designed from Llama 2 to provide accurate, up-to-date information to help guide decisions related to climate change and responses and strategies for climate change. And so yes, they record every step of the model training, the model evolution and adjustment process on the Hedera blockchain using HCS, which we just saw a few moments ago. So how can you find more information about this? You can go to Hugging Face. You can see that they have 3 versions of Climate GPT. They have a 70 billion, 7 billion, and 13 billion parameter versions of this model. If we were to look at the 70 billion variant of this, you can see all the information, the description. You can also see, for example, where the model was tuned from, any data inputs that went into that. And here in this section of model details, you can see information about the entities that were involved in this process. Now, if we were to look at the model lineage, Hugging Face provides this interface where you can see the evolution of these models during development and tuning. So, you can see all the different code components, data components, other models and tokens that go into that process. And as I mentioned before, this is coming from Llama 2, the 70 billion version of it. And so when you click on each one of those components, you can also see more information related to that entity or that component on the right. And there is this little registration section that you'll see for Climate GPT, where there's information about who registered the model, right? This is a cryptographic key. Also anchored on, so this is how they're using the Hedera consensus service to prove that each one of these steps and components was performed, and you have that auditable record and that transparency. So if you were to click on that link there, then you see that information on the Network Explorer with the date and transaction hash information. And if we look at the message information that they're logging, it's content identifiers that anchors this on IRO and IPFS. So again, a very compelling example of how they're using blockchain to document that model lineage and evolution. So that wraps up that second section, and now we can go and look at retrieval-augmented modeling with blockchain. And as we all know, all these blockchain networks and distributed networks, they're a massive repository of great information and data. But accessing that information and interpreting that and deriving actionable, useful insights can be a challenge for many people, right? Because you have to be familiar with data analytics platforms. You have to know what those are. Maybe you have to be familiar with the data structures, the data formats, and it can be a barrier for many. So that is where AI comes into play in this case, right? Because AI can help us extract those insights very easily in natural language, like English, Spanish, and others. And that way, we make that data accessible and useful to many people, right? Developers and non-developers. And what you see here is just a little example of a ChatGPT plugin that I developed to access Hedera historical information there. And we're going to see an example of how to do that as well. And so how can we make this connection between blockchain data and AI? One of the methods that we have available here is RAG. And that just ensures that our models, our LLMs, have up-to-date information that is also anchored or sourced from credible databases. And so that is great because it helps us reduce the probability of model hallucinations and fabricated information. So it all starts with these components. You have your UI, you have your knowledge sources, and the large language LLMs. So we provide a prompt and a query that goes to your interface. The query is formed to help search for that relevant information. That goes to your documents or databases and so on. And that information is then used to enhance the context for the model. So once you have that up-to-date information, you pass the prompt, the query, and that additional context to the LLM, right? So now the LLM is able to generate a much more relevant response that is actually anchored on something that is truthful and sourced. So again, it addresses 2 key problems: the lack of source and the outdated information after a model has been trained. Now, there's an additional mechanism or method that we have, which is called function calling. I like to think of this as a version of RAG in a way. And here you can see the slightly different aspects of each one of these functionalities. And so the primary focus of RAG is to enhance the LLM's knowledge, right, and the accuracy with those external databases, sources, and documents. Whereas when you're doing function calling, you're extending the LLM capabilities to be able to use external tools, APIs, and other functions. So Interaction-wise, the LLM with RAG, it processes that retrieved information like we saw in the diagram, whereas with function calling, the LLM is actually triggering and using external functions. So we're going to see an example of this here. And so what are some examples? Well, answering a question that references a database or a document, whereas for function calling, maybe you're calculating the sum of two numbers, the multiplication, or calling an API to get up-to-date information as well. All right, so let's look at our demo for RAG. And so what I'm going to show you here is how we can use Gemini Pro, this is Google's model, to find information from Hedera, transactional historical information. So what I'm showing here is the first setup that you have to do. You have to kind of create your own project on the Google console. Make sure you go to Vertex, learn more about that. But once you have that all set up, we can come and look at the code. So they make this really easy to get started. So what we're going to see in this code is what would be behind a chat UI, right? So we're going to just look at a code version of it. So we'll start by importing some modules. You can see that from Vertex, we're importing this generative model object, a part, a content, a function declaration, and a tool. So all of those are going to be very important. Here, I just have some credentials to authenticate that this is me working on this project. And here we initialize Vertex with those project credentials. So the first thing that we're going to do is we're going to use this function declaration to tell the model the characteristics of our function, right? The functionality. So here we're going to get the HBAR balance of a specific Hedera account. The HBAR is the native token of the Hedera ledger. And we can also provide some parameters, things that we're expecting and description for each one of those parameters. So the model is going to use those descriptions to identify which function is going to call. In this case, we're only providing one function for simplicity, but you could have hundreds or thousands of functions, right? So this information becomes critical. Then we're going to use this tool object from Vertex to pass a function declaration. And this is basically the function that we just declared in the previous step. So now we have our function declaration and a tool. And this tool is going to be used by the model once we instantiate it. And here is how that is done. We use this generative model class. We specify Gemini Pro. You can use any other variations. In this case, we don't want any temperature. If you remember, the temperature is how creative the model gets. In this case, I want real information that is sourced. So temperature is 0. And then tools, we're passing the tool that we defined in the previous steps so that the model has this ability to access our repositories or our APIs. Here, we start the chat with the model. And here, I just have a couple of accounts that we can play with for the prompts. So again, the prompt that we're going to ask here is, what is the HBAR balance of a given account ID? And so we're going to take that response. And the first thing we're going to do from the response of the model is we're going to extract the information from that prompt so that the model can determine which function to call and how to call it and all that. So I'm doing some fun operations here, but the key thing is we're extracting the account ID from our prompt, from whatever the user entered. And we're forming the endpoint that we want to call in our API. So for context, we're calling an API, a REST API that gives us access to that historical record of transactions on Hedera. Here's my base URL for that REST API. And in the next step, we're going to kind of build together or put together all these components to form the API URL that we want to call. We're going to take that response. If the response fails, we'll send a message to the user. If the response is good, we're going to take this data and print it out. And then the last step is to extract the balance. That's all we're after in this case, right? So we're going to extract the balance from that data. And that is what the model is going to give us back in that response. So if I were to run this, let's see what happens. So that's the walkthrough of the code. Here is the data. So there's a bunch of information in that data, like accounts, aliases, and others. And here we have the balance of that account that we're after. So you can see that now I don't have to, if I were a user, I can build, or a developer, I can build a UI around this, and then my users don't have to know about network explorers, REST APIs. They can just ask in plain English. And let's go and modify our prompt really quickly here. Let's change the account just to make sure that this is actually being dynamic. And if we run this one more time, this other account has a different balance of almost 300 HBAR. So that is how you can use RAG, or Retrieval-Augmented Generation. All right, coming back to our slides. So I wanted to provide also some context, right? Because I was talking about transactional and historical information from Hedera, so I think it's important that we understand where this information is coming from. So on Hedera, we have this mainnet, and we have mirror nodes. So mainnet is the set of nodes that process transactions, that order them and timestamp them. And you have the mirror nodes, which provide all the history. So that is what we were using, or that's what we were using with this REST API. And on top of that foundation, that's where we have other services, like the consensus service that we talked about. There's other services for tokenization, which allows you to create fungible and non-fungible tokens without the need for smart contracts. So if you're coming from the Web 2 world, you can easily integrate these Web 3 components in languages and frameworks that you already know, like Java, JavaScript, and Go, and others. And of course, if you want all the programmability and flexibility and automation from smart contracts, we're EVM compatible, so you have that ability there. And so this part of the stack is all governed by the Hedera Governing Council. That is the governing mechanism of the network. And on top of that foundation, that's where we see the use cases that you as developers and builders would create to add value to the end users. That could be individuals, enterprises, governments, IoT devices, and so much more. All right, so I know we've covered a good amount of ground today. So, the key takeaway is that AI and blockchain work really well together. We started by looking at the tremendous upside that both of these technologies have, right? We talked about the 5 key application areas around data integrity, model lineage, content authenticity, decision making, and so on, and RAG. And then from those 5 application areas, we focused on data integrity, model lineage using HCS, and we saw how RAG can help us get information that is sourced and up to date from blockchain data sources. All right, so you're here already. You're taking steps to learn more. Make sure you take action. Take the next step today. You can try this code that we saw today. And you can also visit our Hedera booth. We're right there. So if you want to have a more in-depth conversation, any questions, we're more than happy to talk to you. So hopefully next time that somebody asks you, what do you think about when you hear AI? Rather than thinking about these things, you'll think about how you can work with blockchain and AI with Hedera to advance the development with these technologies. So that is all I have. So thank you very much for your time today.